All right, we're gonna find the Q value here for the following reactions, and the Q is either the energy, it's the energy change, right? So it either um, releases energy or it requires energy for it to happen, right? So let's look at this thing. Let's unpack that. This is a lithium 7 atom bombarded by a proton, releasing a alpha particle, and the resultant nucleus is a helium atom. Now, understand that these are both the same thing. These are two ways of writing the same thing, right? So that's kind of an interesting reaction. But let's take a look at this. Let's write it. I like to write the formula so we know what we have, right? Okay, so we've got a 7, 3 lithium plus a 1, 1 proton, right? Which will, by the way, for a proton, we'll use this. Okay. That turns into a 4, 2 alpha particle plus a helium atom, right? Now, by the way, these are both the same thing, so we're just going to look up helium-4 for that, okay? And then we're set, right? So let's look at the total mass here. So lithium-7 is here. So we go 7.016004 plus, and then for a proton, use hydrogen, 1.007825. Okay. And then that becomes 4, 2, we're going to just use 2 heliums, right? So 4.002603 plus, and then helium is, of course, we just use helium. For helium, look up helium. Okay. So we're going to look at the mass here. Total mass. So on the right side, we got 4.002603. And then there's 2 of those, so I'll go times 2. And this mass on the right side is 8.005206. And then let's look at the mass on the left side. So 7.016004 plus 1.007825. Ooh, this is getting crazy here. Okay, so this is 8.023829. Okay, so notice that there's less mass. We lost mass, right? So whenever you lose mass, you have to ask, where did it go? Where did that mass go? And the answer here is that it gave off energy. This gave off energy, so plus energy, right? Okay. Now, if you ever gain mass, you always have to ask, where did it come from? Yeah. And if you put that all together, you've got, where did it come from? Where did it go? Where did it come from, Cotton Eye Joe? Sorry. Okay, so the change in mass, the loss of mass here, okay, is, let's figure this out. Okay, so my change in mass is we lost 0.018623, right? Okay, what this means is that this is how much mass turned into energy. So I'm going to multiply that by 931.5, and we get 17.347. 7 says 17.35 MeV released. Right? So that means that it's exoergic. Okay? The other thing that you might notice, so Q values, by the way, that are heat released are positive. Okay, so if it gives off heat, we want to give this as a positive number. Notice that the mass decreased. Okay, we had a negative change in mass, But the reason that the Q value is positive is that because that mass turns into energy. It's not energy we require, it's energy that's released. Okay, so when energy is released, it's positive. So positive Q is released. A negative Q means it's like a deficit. You've got to make up for that, right? That means required. Like postage due. Okay, so there we go. So we say that it's exoergic, right? All right.